We proceed to the third case of the integration of rational functions by the use of partial fractions. So here in the third case, we have to deal with this form. So wherein the denominator of your rational expression can be factored into linear and quadratic factors, and none of the quadratic factors is repeated. So for example, we have this integral. The integral of 3x squared plus x minus 2 dx all over x minus 1 times x squared plus 1. So as you can see, the denominator of your rational expression has a linear factor, which is x minus 1, and a quadratic factor, which is x squared plus 1. So this means we can decompose by partial fraction our rational expression into two components. So one for the linear factor x minus 1, and the other for the quadratic factor, which is x squared plus 1. So take note, if we have a linear factor in the component, so its numerator is symbolized by a single coefficient or a single variable, while for the quadratic factor, we have an entirely different numerator. So if we have a quadratic factor, its numerator is a linear expression. This means we have to solve for the coefficient of variable x and the other the constant. So by the use of LCD, the numerator 3x squared plus x minus 2 is just equal to your a sub 1 times x squared plus 1 plus x minus 1 times a sub 2x plus b2. So at this point, we're going to solve for coefficients a1 or for the variables a1, a2, and b2. So we substitute some values of x in our equation. So if x is 1, we get a1 equal to 1. If x is 0, your b2 is equal to 3. And if x is 2, we get a value of a2, which is 2. So we're going to substitute the values of these three coefficients in our components. So therefore, our integral 3x squared plus x minus 2 dx all over x minus 1 times x squared plus 1 can be expressed into the integral of dx over x minus 1 plus the integral of 2x plus 3 dx all over x squared plus 1. So the first integral is quite easy to compute. This can be solved by ln. Here, we can decompose this integral into two components. So we have integral of 2x dx over x squared plus 1 and the integral of 3 dx over x squared plus 1. So the second term here can be solved by simple substitution, or you can solve this by the formula of ln, the same with the first term. For the last term, this can be solved by the arctan formula. So therefore, the integral of these three terms is equal to, for the first one, we have the ln of the absolute value of x minus 1. The second, we have ln of the absolute value of x squared plus 1. And the third, or the last term, we have plus 3 arctan x plus c. We proceed to our second example, integral of x squared plus 2x minus 1 dx all over x cubed minus 27. So our denominator x cubed minus 27 can be factored into x minus 3 times x squared plus 3x plus 9. So this means we can break our rational expression into two components or two fractions. Okay, one for x minus 3 and the other for the quadratic factor, which is x squared plus 3x plus 9. So again, for the linear factor, its numerator is a single coefficient, or we have a single variable here, while for the quadratic factor, we have a linear expression in its numerator. So we proceed to our equation, which is the numerator x squared plus 2x minus 1 is just equal to a1 times x squared plus 3x plus 9 plus a sub 2x plus b2 times x minus 3. So we solve the coefficients a1, a2, and b2. So we substitute some values of x. So if x is 3, we get the value of a1, which is equal to 14 over 27. When x is 0, we are left with an unknown variable b sub 2. So therefore, b sub 2 here is equal to 17 over 9. And when x is equal to 1, a2 is equal to 13 over 27. So therefore, our integral can be decomposed into the integral of 14 over 27 dx all over x minus 3 plus the integral of 13 over 27x plus 17 over 9 dx all over x squared plus 3x plus 9. The first one we can use, or we can solve by ln. The second one, we can further use some methods here. Okay, so take note, the denominator x squared plus 3x plus 9, if we do some completing the square, so your x squared plus 3x plus 9 is just equal to this expression. You have x plus 3 halves square plus 27 over 4. So we let y be equal to your expression x plus 3 halves. So this means if we solve for x, we get y minus 3 halves. So I'm going to show you how we did the completing the square in this part. So your x squared plus 3x plus 9. So if we apply completing the square, we have x squared plus 3x plus, so we add something. So this something is equal to your coefficient 3 in your x divided by 2, and then we square the value. So we copy plus 9. So to maintain the equality, we have to subtract the added value here, which is minus 3 over 2 squared. So this means this is equal to x squared plus 3x plus 9 over 4 plus 9 minus 9 over 4. So we factor this expression here. So this is equal to x plus 3 halves quantity square. We combine these two and you have 27 over 4. So this is how we get this equivalent expression. Okay, so at this point, let's continue. So we get the derivative of dy, or we differentiate both sides of this equation. So your dy is just equal to dx. So this means your dx here will be replaced with dy, and our x here will be replaced with y minus 3 halves. And our numerator, our denominator here will become y squared plus the quantity square of square root of 27 over 2. So therefore, this integral can be expressed into the integral of 13 over 27y plus 7 over 6 dy. So we do the substitutions. That means we substitute all these values for x, for dx, and for our denominator so that we get this integral form. So we have the integral of 13y over 27 plus 7 over 6 dy all over y squared plus the square root of 27 over 2 quantity square. So we can break this integral into two parts. One is 13 over 27 integral of y dy over y squared plus square root of 27 quantity square. The other one is this part. We have plus 7 over 6 integral of dy all over y squared plus the square root of 27 over 2 quantity square. So the first integral, or this first form, can be solved by simple substitution that will lead to the ln formula. And the other one can be solved by the arctan formula. So therefore, this integral is equal to 13 over 54 ln of the absolute value of x squared plus 3x plus 9. And the second one is equal to plus 7 over 9 times square root of 3 arctan of 2x plus 3 over 3 square root of 3 plus c.